Good morning. हाँ Good morning. Online students, am I audible? Let me know. Yes. आप पहली बार आए? अभी तक के लेक्चर्स देखे आपने? नहीं. आपके हो गए अभी तक के? अभी तक सारे देख लिए आपने लेक्चर? नहीं. We were dealing with LCM last time. अच्छा. सारे ही कर लेते हमने. All the PYQs we covered. ओके. आप लोग देख लेना जो भी वीडियोस है अभी तक के 7-8 होंगे, और अगर कुछ डाउट हो तो आस्क मी. Last time we covered LCM and HCF, wherein any given two or more numbers we find out prime factorization, and for highest common factor we look for common prime factors and what is the maximum power of those prime numbers that is common in all the numbers. And for LCM we ensure that every prime factor that is there in each of the numbers should appear in the LCM, and least possible power that is required for number to be factor of that particular number. For example, if I take any two numbers, let us say m is equal to 2 raised to 7, 3 raised to 8, 5 raised to 9, 7 square, 11 cube and 13. Okay, any random number I am taking. N is equal to if I have these three numbers, what would be the HCF or highest common factor of these three numbers? What would be the HCF of these three numbers? For HCF, I need common factors. What is the common prime factors of this? 2 is common in all three, 3 is common, and 5 is common, and that is all. Only 3 common factors are there. And what is the maximum power that is common? 3. इसके पास 3 ही है, 3 से ज्यादा हो ही नहीं सकता. तो 2 raised to 3, 3 raised to 8, 5 square. ठीक है, उतना ही है उसके पास. So that is the maximum power that is common. Other than that, there is nothing common. No common factor other than these three numbers, and these are the maximum possible powers that are common. So this is the highest common factor. And for same three number, if I have to calculate LCM, what would it be? 2 raised to Now because I am calculating LCM, which is least common multiple, so that number has to be multiple of all the three numbers. Multiple होना चाहिए, common multiple. For common multiple, I need LCM to be multiple of all these three numbers. So for LCM to be multiple of M, you need all those prime numbers there in the LCM. For LCM to be multiple of N, you need LCM to be multiple of all these prime numbers and all these prime numbers as well, and to the respective power. So for LCM to be, LCM will have 2 definitely, because the 2 is everywhere. But what power? Because this number M has to be factor of LCM, 7 तो आना ही चाहिए, at least 7 should be there. For again 3 will be there in the LCM, but for O to be factor of LCM, you need at least 21 maximum among those. 5 has to be there, but for these two, M and O, to be power factor of these LCM, you need at least 9. Then next 7 is there, 7 square has to come. What else? 11 has to be there, but 11 cube has to come. 13 has to be there, and 17 square. This is the LCM. When we have prime factorization of given numbers, you can calculate HCF and LCM in one step. Okay? That is what we covered in last class. Last class में किया है, आप देख लेना. अभी of course directly final step करूँगा तो आपको नहीं समझ में आएगा. Last class में we have covered this. Today we'll cover fractions. Fractions भी start तो किया ही था हमने ना. Fractions also we had started. So we had talked about proper fractions, improper fractions. What is proper fraction? Numerator by denominator, wherein numerator is smaller than denominator, right? Improper fraction when denominator is smaller than numerator. Then mixed fractions, there is some integer followed by a fraction. It can be written as 4 plus 1, 4 1 by 2 is 4 into 4 plus 1 by 4. So 17 by 4 it can be written as this. 4 complete and 1 by 4 with fraction. It is nothing but 4 plus 1 by 4, which is same as 17, 4 into 4 plus 1 by 4. All these are equivalent. These are called mixed fraction. Doesn't matter, I mean, if you don't remember, mixed fraction is okay, but this terminology you should remember, because sometimes UPSC puts that in their questions, that proper fraction this. So you should not be confused about what is proper fraction. Other than that, not much important. Then we are looking at properties of fraction. Fraction is nothing but numerator by denominator kind of thing. This division, basically A divided by B. A by B is A divided by B, and here A and B both are integers. Okay. So they can be positive, negative. Integers can be negative as well, minus 3, minus 2, minus 1, and 0, 1, 2, 3. The only condition is this B cannot be 0, because we don't divide by 0. That is not allowed in mathematics. So if denominator is 1, fraction reduces to integer. That is property number 1. So if we have 5 by 1, it is nothing but 5. 5 by 1 is 5. 5 divided by 1. You divide number by any, if you divide any number by 1, then you get itself, right? Minus 3 by 1, which is nothing but minus 3, integers. So if you divide any number by 1, you get integer itself. Secondly, if numerator is 0, then fraction is 0, because 0 divided by anything is 0. 0 by 11 is 0. 0 by anything, 1, 2, 3, 4, 5, 6 is 0. 0 divided by anything is 0. Then fraction doesn't change if both numerator and denominator are multiplied or divided by same number. So if you have a and b, if you have a by b, you multiply it by same number. Like here we have multiplied by n. Then fraction does not change because this n gets cancelled and these two are equivalent. A divided by b divided by n. Again, this n cancels out because division is nothing but reverse of multiplication. A divided by b upon b divided by n is equal to, I can write it like this, a by b, b by n. I can write this a divided by b, and this division is nothing but reverse of multiplication. A divided by n, right? And this again n cancels out and you will get a by b. So if you multiply or divide fraction by same number in the numerator and denominator, fraction does not change. We had covered this also in the last class, right? ये भी किया था. Then we saw some examples to confirm this. लास्ट क्लास में जो क्वेश्चंस दिए थे, क्वेश्चंस किए हैं? हाँ, क्वेश्चंस किए क्या? लेकिन HCF LCM के क्वेश्चंस दिए थे ना होमवर्क के लिए. हाँ, तुम मुझे बना लो, है ना? नहीं दिए थे, मुझे याद है. HCF LCM we had homework problems, वो किए क्या? नहीं, किसी ने भी नहीं किए. कमाल है. कल आज कर लेना. टुमारो विल वेरीफाई द आंसर. आप लोग भी ट्राई कर लेना. क्वेश्चन जो है इनसे ले लेना, बस वो फोटो ले लेना. हाँ, question that we are now dealing with is when are two given fractions equivalent? And we are saying that if we have something like this and we cross multiply a into d, c into b, and if those multiplications are equal, we conclude that those two fractions are also equal. If we have, let us say, 5 by 7 and we have 25 by 35, we want to comment on whether these two are equal or not. One way is you divide by the same number, you reduce it, divide by 5, it remains 5, it remains 7, and you get equivalence, no problem. Another way is you check by cross multiplication. 35 into 5, it is nothing but kitna hai? 175, and second is 25 into 7, which is also 175. Since multiplication or cross product is equal, we say that fractions are equal. Okay, and ये भी किया था ना लास्ट क्लास में. Okay, we had checked if these fractions are equal or not in the last class. Then we talked about terminating and non-terminating fraction. These are nothing but when we try to convert this fraction into decimal, do they terminate or do they have finite number of digits after decimal point or infinite number of decimal, infinitely many. So we tried to divide 1 by 2. It was nothing but 0.5. So it was terminating fraction. एक के बाद खत्म हो गया, terminate हो गया. Similarly, we tried 1 by 8. How did we divide? Because 1 is clearly less than 8, we will get 0 point something. Whenever we add point, you will get 1 0 because we are going to 1 by 10th place now from unit place. So you get 1 0 here. 8 ones are 1. 10. Now we are dividing 10 by 8. 8 ones are 1. Remainder is 2 because we are again shifting to the right. Another 0 is borrowed. 2 0. 8 2s are 16. Remainder is 4. 20 minus 16 and 4 0. So we get 8 5s are 40. That was the fractional representation of 1 by 8. So you'll get again terminating fraction. Khatam ho gaya, terminate ho gaya. But if we try to convert 1 by 3 into fractions, we'll again follow the same process. 0 point, you'll get 1 0. 10 divided by 3, 3 3s are 9, 1 0, again 3 3s are 9, again 3 3s are 9, again 3 3s are 9, and so on till infinity. So this is what we call a non-terminating fraction, right? Okay. Instead of writing it like this, we wrote it as 0.3 bar. What else did we see? Yes, some group of digits can start to repeat till infinity after some point. Like this is 1 2 3 point, 1 2 1 2 1 2 repeating till infinity. We have 0.22, then 3 4 5 6, 3 4 5 6, 3 4 5 6 repeating till infinity. It is starting after 0.22 and then 3 4 5 6 is repeating. And now our next target was to convert this fraction into decimals and decimals into fractions. That was our target. Converting this into fraction, like terminating decimals into fraction, was very easy because you can simply multiply by relevant power of 10 and get the fraction. So 0.5, you will just multiply it by 10 and divide it by 10 because you don't want to change the value. So you will get 5 by 10 multiply by 10. So it will shift by 1 decimal point, will shift to the right, and we have to divide by 10. So it is 5 by 10. We can reduce it to say 1 by 2. Similarly, this 12.123, it is nothing but we multiplied by 1000 because there are 3 digits after decimal point. So 1 2 1 2 3 divided by 1000. This is the fractional representation of this. And if there is a different fraction in the option, we probably have to reduce it by dividing by some numbers. This whole terminating fraction, it was very easy. The challenge is with the non-terminating fractions, and there we have to make multiple cases. I told you the method how to go about it. Our idea is to get rid of the repeated part after decimal point. That was our idea. So what we did was, if we have this 0.333333 and we want to convert this into fraction, we firstly multiplied by 10. Why 10? Because only one digit is repeated, and my main idea or main motivation is to get same numbers after decimal point. So if I try 10x, I will get 3.333333 and so on. Bas ek point shift ho jayega, rest of the digits are same. And when I subtract now, when I subtract this number from this number, this entire part will get cancelled because it is same. So I'll get 10x minus x is 9x is equal to 3. So x is equal to 3 by 9 or 1 by 3. That was my basic core idea, that I want to get rid of this infinitely many times repeated part so that I'll get a fraction. Core idea remains the same even when you take multiple cases. This was the simplest case. What was the case? Case was when repeated digits start immediately after the decimal points and only one digit is repeated. Repeated part starts immediately after decimal points. That was the case. Then we saw some examples of this, like if I have 0.232323 and I want to convert this into fractions, then I do nothing, I write x, then because two digits are repeated now, 232323, I have to multiply it by 100. Again, core idea is that I have to get same numbers after decimal point ताकि मैं subtract कर सकूं. Main idea subtract करने का है, इसलिए if I multiply it by only 10, I will get after decimal point 323232. But here we have 232323. That is why I have to multiply by 100. I'll get 23.2323 and so on till infinity. Now I subtract and I'll get 99x is equal to 23. So x is equal to 23 by 99. Okay. In general, if you have any repeated or non-terminating fraction that starts where such that repeated digits start immediately after decimal point, मतलब इसके बाद ही repetition start हो रहा है, कितने भी digits हो, like something like 1 2 3 4 bar. If something like this is there, then working rule is जितने भी नंबर है उतने डिवाइडेड बाय 9999 कर लो, उतने टाइम्स 9 से डिवाइड कर लो, तो इट वुड बी 1 2 3 4 डिवाइडेड बाय 9999. If there is 0 here and repetition starts immediately after decimal point. If you want to remember these working rules for each of the variants, you can. Otherwise, this process is self-explanatory. This is also two-step process. Exam में करना इतना difficult नहीं है. If you don't want to remember the formula, that is absolutely fine. You can use your ability to remember in your GS or optionals or somewhere else. You can here you just do manually. एक ही स्टेप में यहाँ पे भी आंसर आ ही जाता है, ऐसा नहीं कि बहुत टाइम लगता है. बट वर्किंग रूल भी याद रख सकते हो. बट फॉर एवरी केस देन यू हैव टू रिमेंबर द वर्किंग रूल, बिकॉज यहाँ पे दो चीज है. यू हैव टू हैव 0 इन द इंटीग्रल पार्ट एंड रिपीटेशन हैज टू स्टार्ट इमीडिएटली आफ्टर द डेसिमल पॉइंट. व्हाट हैपेंस इफ वी हैव नॉन जीरो नंबर एट द इंटीग्रल पार्ट? इफ वी हैव 1 2 and point, let us say 2 3. If we have this number as x, so 2 3 2 3 2 3 till infinity. If you have this, how do we convert this into fraction? Idea remains same, that we have to get same repeated part after decimal point and then subtract. Again immediately start होता है, repeatable part starts immediately after decimal point and two digits are repeated. So what should I multiply it with? 100. What is 100x? 1223.2323 and so on. And now I subtract. What do I get? I get 99x is equal to 1223 minus 12. This parts get cancelled and 1223 minus 12, 1 2 1 1, and so x is equal to 1211 divided by 99. So you cannot directly write 1223 divided by 99. Here you have to, working rule would be, if you have non-zero part in the integer and repetition immediately starts after the decimal points, then you take the whole number disregarding decimal point, subtract the integral part from it and then divide by however many times digits are repeating. समझ रहे हो? नहीं. if I have something like, let us say 5.778 and it is repeating. If I have something like this, so I have non-zero part in the integral, then repetition starts immediately after the decimal point. यहाँ पे वर्किंग रूल क्या होगा कि मैं पूरा नंबर ले लेता हूं, पूरा नंबर मीन्स 5778, then I subtract the integral part from it, I get 5773 and जितने भी बार डिजिट रिपीट हो रहा है that many number of nines I divided. That would be the answer for this. Similarly, अब बताओ मुझे इसका क्या होगा. इसका क्या होगा? What would this convert to? Non-zero part in the integer. Repetition starts immediately after this. So we take entire number, subtract. हाँ जो भी है, मतलब you have to take this number 70819, you have to subtract 70 from it, right? So you will get 9, this 70749 and 3 times 3 digits are repeating, so you will get divided by 999. ठीक है, you can see this otherwise also. You have this x, because there are 3 digits after decimal, you have to multiply it by 1000, you will get 70819.819 bar, and if you subtract you will get 999x is equal to 70819 minus 70. वही हमने किया. ठीक है, ठीक है. Case where immediately after decimal point digits starts repeating. Now the next case would be थोड़े टाइम बाद रिपीट होंगे. For example, if I have let us start with 0.12 bar, right? So 1 2 2 2. How do we convert now? What do we already know? That if repetition starts immediately after the decimal points, then I know how to handle. So let us convert this into that kind of form, that where repetition form starts immediately after decimal points. कैसे करेंगे? Huh? Right, 10 से, if I multiply this x by 10, if I multiply this x by 10, what I'll get? I'll get 1.22222, right? Now I know how to handle. अब तो आता है मुझे. Now I can multiply this number by 10 and I'll get same repetition. So if I multiply this by 10, 10x by 10, I'll get 100x is equal to 12.2222 and so on. And I subtract this from this, then everything in the points get cancelled. If I subtract 10x from 100x, I'll get 90x is equal to 12 minus 1, 11. X is equal to 11 by 90. Right? Niranjan, idea समझ गए? We already know how to handle when repetition starts immediately after the decimal point. I don't know how to handle this, so I convert it into something I already know. I multiplied by 10 to convert the number into repetition, so that repetition starts immediately after the decimal point. So 10x is this 1.2222. Now I already know this. I don't even need to do this also. I know that this is equal to, I take entire number minus 1, 11 and 1 repetition So I'll have 11 by 9, है ना? If we apply our working rule to this number, I take entire number which is 12, then integral part I subtract from it, and whatever number of digits that are repeating, that many 9s I write. So I'll get 11 by 9, which is 10x. So x is equal to 10 से इधर divide कर दो 11 by 90, which is what we got anyway. Right? Let us try some more. 0.7812 bar. ऑनलाइन स्टूडेंट्स समझ में आ रहा है? Yes, there are cases that we are making. Ultimately, we can remember one case and extrapolate everything from there, or you can just remember what is the core idea, how we are trying to convert these numbers into the case which we know. Now, what happens here? हो गया? क्या है? अच्छा 9900 आएगा कहीं ना कहीं. तुम्हारा क्या है? हाँ वो नहीं, आपका 99 7811 by 99. ये वो 0.1 से छोटा है, वो ये 1 से छोटा है. अच्छा 00 भी है ना. ओके, मैं सोच रहा हूँ इतना बड़ा कैसे आ गया. So if we multiply it by 100, we'll get something we like, where repetition starts immediately after the decimal point. 100x is equal to, you'll get 78.121212 and so on. Because two digits are repeated, again I multiplied by 100, so I get 10,000x is equal to 7812.1212 and so on. Now I subtract this minus this. 10,000 minus 100 is 9900x is equal to 78, this gets cancelled, 7812 minus 78, क्या आ रहा है? हाँ 7734, right? So x is equal to 7734 divided by 9900, and you can reduce it. दिख रहा है कि 2 से तो divisible है दोनों, so you can divide numerator and denominator by 2, and you can check which other numbers it is divisible by. 3 से भी है divisible, है ना? 3 से भी divisible है. ठीक है. Instead of doing this, the working rule is write this entire number down, 7812 minus the part which is not repeated but is after decimal point, minus 78, and divided by as many 9s as there are repeated digits. So 2 repeated digits, and as many zeros as there are digits between decimal point and the repeated part. So 2 zeros again, which is what we got. For every case you will have to remember such kind of working rules if you want to remember, but if you practice like 10 क्वेश्चन हर किसी का कर लोगे 5 क्वेश्चन तो वो भी याद रह जाएंगे, कोई बड़ी बात है नहीं. इवन इफ यू डोंट रिमेंबर दैट इज आल्सो फाइन. 4 स्टेप में आंसर आ जाएगा कितना भी कॉम्प्लिकेटेड सवाल हो. और यू कैन डू समवेयर इन द मिडिल. यहां तक आ जाओ और इसके लिए वर्किंग रूल याद रख लो, वेयर रिपीटेशन स्टार्ट्स इमीडिएटली आफ्टर द डेसिमल पॉइंट. What was the working rule for this? We firstly write it as in terms of bar, right? Then we forget that there is decimal 7812 and we subtract the integral part, and as many 9s as there are repetitions, so only 99. So ये क्या 7734 by 99 is 100x. So x क्या होगा, 100 से डिवाइड करोगे दोनों साइड, so you will get the same answer, right? 9900. Answer would be same. So you do this or come here and write working rule, or remember different working rules for different cases. Anything is okay as per your comfort zone. Then let us try this now. 12.734 bar. क्या हुआ? 1512507. ये आ रहा है सबका, ये आ रहा है. 9900 आ रहा है. नहीं यार 3 ही है ना बाद में, तो एक ही आएगा. 2 9s for the 2 repetition and 1 0 for the digit in between. Let us first multiply by 10 to get the number to our comfort level. You have 34 bar, and here we can apply the working rule. 12734 minus 127 divided by 99. ये होगा, ये क्या है, 0612 divided by 99, it is 10x. So x is equal to, you can just divide it by 10. That will be your answer. Also you can do, now from here you can multiply it by 100, you will get 1000x is equal to 12734.34 bar. When you subtract, you will get 990. X is equal to 12734 minus 127. This gets cancelled and you get the same answer after one extra step. Yes, Ashwini, that is correct. Correct, Amrita. Fine. Let us look at the booklet. What are the cases that we have made there? First, we start with the simplest. Simplest is recurring digits start immediately after the decimal point. That was our case number 1. Firstly, we considered our 0 point immediate starting of recurring. So here we have 0.3333. Our basic or core method was we try to get same number of digits after decimal point, so that when we cancel, they get cancelled out and I don't have to deal with infinitely many digits. So we multiply by 10, we get the same number of same digits after the decimal point, and when I subtract x from 10x, this repeated part gets cancelled and x I get value as 3/9 here. By the same logic, you can try these numbers. Directly बता दो क्या क्या आंसर्स होंगे. First, it would be 12/99 होगा वो directly, right? 12 is repeating, 1 2 is repeating, so and there is 0 point something immediately after decimal points भी start हो रहा है, 0 भी है integral part में, तो सीधा 12 divided by 99 होगा वो. You can multiply by 100, you will get 12 point something, a 12 point same number. So when we subtract 100 minus x, 99x is equal to 12, x is equal to 12 by 99. This number we have 423 repeat हो रहा है. We have 423 432 divided by 999. जितने भी बार डिजिट रिपीट हो रहा है, जितने भी डिजिट रिपीट हो रहे हैं उतने बार 9 लिखेंगे. थर्ड वन, हाँ, $123 माइनस इंटीग्रल में जितना भी है डिवाइडेड बाय जितने डिजिट रिपीट हो रहे हैं 99. That is the working rule. If you want to write the entire thing, you can write it as x. You can multiply it by 100. You will get 100x is equal to 123 point same number. 100x minus x, 99x is equal to 123 minus ये 1, which is 122, and x is equal to 122 by 99. ये बता दो लास्ट वाला. डायरेक्टली आ जाएगा. So we divide by 999, 999, etc. depending on how many digits are recurring. ठीक है. This was our basic case. Second case was recurring starts after few digits. कुछ digit बाद recurring start होगा. Like 0.1 and then recurring starts 333333. Method is same. वो हमने देख लिया. We write it as x. Our goal is to get same digits after decimal point, so that when we subtract they get cancelled. So firstly ऐसे तो हो नहीं सकता. Firstly we'll get it to 1.3 bar such that recurring starts immediately after the decimal point. तो वहां तक आ गए, 10 से मल्टीप्लाई करके 1.3333 आ गया. Now we know how to deal with it. For this number we can multiply by 10 and get the same number of digits after decimal point. So for 10x we get 100x and 13.3333 आ गया. Now we can subtract 10x from 100x and you will get 13 minus 1 12. So 12 minus 90 आ जाएगा. So x will be equal to 12 divided by 90, right? और वर्किंग रूल भी हमें पता है. For this number it is equal to for using case 1, you get, we forget that we write it firstly as 13 bar, then 13 minus 1 12 माइनस अपॉन जितने भी रिपीट हो रहे हैं उतने डिजिट्स, एंड दिस इज अवर 10x। तो x क्या होगा, x का x के लिए 10 से डिवाइड करेंगे। रूल हर जगह पे मैंने लिखा है, write as many nines in the denominator as recurring digits followed by certain number of zeros, and number of zeros is as many digits there are between recurring part and the decimal point. तो यहाँ पे we had 1 point, in above case we have 13 minus, and in the numerator difference between the number after decimal taking recurring part only once and non-recurring part. हमारा नंबर क्या था यहाँ पे नंबर था 0.13 बार, राइट। तो हम क्या बोल रहे हैं, वी राइट एज मेनी नाइन्स इन द डिनोमिनेटर एज देयर आर रिकरिंग डिजिट्स। कितने रिकरिंग डिजिट्स है, 1 है, तो विल राइट 1 9 फॉलोड बाय नंबर ऑफ जीरोज। अब कितने जीरोज है, हाउ डू वी डिटरमाइन नंबर ऑफ जीरोज आफ्टर दिस 9, दैट देयर आर नंबर ऑफ डिजिट्स बिटवीन रिकरिंग पार्ट एंड द डेसिमल पॉइंट। रिकरिंग पार्ट और डेसिमल पॉइंट के बीच में कितने डिजिट्स है, 1 है, बस एक ही डिजिट है ना, so we write 1 0 here, and in the numerator we take difference between number after decimal taking recurring part only once and non-recurring part। 13 लेंगे एंड उसमें से एक सब्ट्रैक्ट करेंगे, पूरा 13 लेंगे उसमें से एक सब्ट्रैक्ट करेंगे, so we will get 12। अनदर क्वेश्चन, अनदर एग्जांपल यहाँ पे लिखा है 0.3345, 45 रिपीट हो रहा है, राइट। तो 2 digits are repeating, so we'll write 9 2 times, 9 9, and there are 2 digits between decimal and repeated part, we'll write 2 zeros, and in the numerator we'll write 3355 minus 33, that is the working rule for this। If you don't want to remember this, you can multiply it by 100, you will get 100x is equal to 33.45। now we apply working rule to this, or again multiply by 100, subtract and get the fraction, answer same ही आएगा। Here you will have some more remembering to do, there you can perhaps do with little less। यहाँ पे 1 स्टेप में आंसर आएगा, वहां पे 2-3 स्टेप लिखना पड़ सकता है, दैट इज ऑन द ओनली डिफरेंस, बट दैट इज ऑल्सो क्वाइट डूएबल इन एग्जामिनेशन हॉल। एग्जामिनेशन हॉल में यू हैव 2-3 मिनट्स टू सॉल्व 1 क्वेश्चन, इतना तो है ही टाइम, कोई टेंशन नहीं है, ये भी कर सकते हो एग्जाम हॉल में। हर बार वो मतलब वो रटने की जरूरत है नहीं, ये बता रहा हूं मैं, जिनको रटने का मन है वो रट सकते हैं वो प्रोसेस, नो प्रॉब्लम। जिनको नहीं है मन, दे आर ऑल्सो फाइन, यू विल परहैप्स टेक 10-15-20 seconds मोर, which is equal, which is like okay in examination hall, like exam like UPSC में चलता है। आपकी कोई बाकी बैंकिंग वगैरह के एग्जाम में where you need speed, there perhaps this would be required, but otherwise you can simply get remember the core idea। कि हमारा core idea क्या था, core idea was always to get recurring part start immediately after the decimal point, and from there on to multiplied by some power of 10, so that again the recurring part appears there and we subtract and it gets cancelled out। core idea वही था, हमेशा कैंसिल करना था हमें पूरे रिकरिंग पार्ट को, और उसके लिए पहले उसको इमीडिएटली आफ्टर डेसिमल पॉइंट चालू होना चाहिए। दैट वाज आवर फर्स्ट स्टेप, दैट मल्टीप्लाइड बाय पावर ऑफ 10 सच दैट रिकरिंग पार्ट इमीडिएटली चालू हो। जितने भी मतलब रिकरिंग अगर 3 डिजिट्स है, 4 डिजिट्स है, कितने भी हो, वो रिकरिंग एज अ बंच should start immediately after the decimal point, that was our idea। and एक बार वो आ गया, उसके बाद इधर हम वर्किंग रूल दे जा सकते हैं, या फिर again we can multiply it the new number with relevant power of 10, so that वो recurring part cancel हो जाए पहले वाले नंबर से। that was the core idea। solve all these questions, चलो ये करते हैं। all these questions, Okay. ऑनलाइन स्टूडेंट्स कर रहे हो ना? डन, गुड. हो गया, हो गया. हो गया निरंजन? हो गया? कौन सा बचा है? सेकंड लास्ट तो कैसे कर रहे हो? आर यू अप्लाइंग वर्किंग रूल और वो पूरा मल्टीप्लाई करके कर रहे हो? हाँ, अच्छा, ठीक है। So you are multiplying first number by firstly 100 to get repeated part immediately after the decimal point, है ना? 100x is equal to you will get 12.0505 and so on. And from here क्या कर रहे हो? ओके, यहाँ पे भी 100 से मल्टीप्लाई कर रहे हो, ठीक है। Whatever suits you, you can again multiply by 100, so you'll get 10,000 x is equal to 1205.050505. अब subtract करोगे तो this entire thing will get cancelled and you will get 9900x is equal to 1205 minus 12, which is 1193. Well, x is equal to 1193 divided by 9900. That would be the answer. Okay. अश्विनी, तुम्हारा फर्स्ट अलग आ रहा है क्या? अमृता, सॉरी। समझ गया ना कैसे करना है? सेकंड का बताओ आंसर बस। वी हैव 2 डिजिट्स रिपीटिंग, वर्किंग रूल से ट्राई करते हैं, एंड 2 digits repeating and there are 2 digits between decimal point and repeated part, so you will get in the denominator you will have 9900 definitely, and in the numerator we will have 2243 minus 22, so we will have 2221. यही आ रहा है? यही आ रहा है ना? yes, yes. Third, we'll have 1 2 3 4 repeating, right? 1 2 3 4 is repeating, so in the numerator, in the denominator we'll definitely have 99990, and in the numerator we have a 51,234 minus 1 2 3 4, ये है ना? फाइव 1 2 3 4 minus 5, ये in the numerator we'll have 5 1 2 2 9, ये हो। यही आया सबका? गलती नहीं हो रही है ना? सही आया? यही आया ना निरंजन? सेम आंसर ना? What you can do is you can again multiply by 10. 10x is equal to 5.1234 आएगा बार. Now you multiply by 10,000, है ना? So you will get here 1 lakh is equal to 51234.1234 bar. Now you subtract, you will get 99990x is equal to again 5 1 2 2 9 because this gets cancelled and you get the same answer. कोई भी मेथड से कर लो आंसर सेम आएगा, दोनों से भी बहुत ज्यादा टाइम नहीं लगता है. इफ यू रिमेंबर द वर्किंग रूल इट इज फास्टर. यस. थर्ड, only one digit is repeating and one digit in between, you will get 90 and 35 minus 3 32, 32 by 90. सही है ना, सबका यही आ रहा है ना. नेक्स्ट you have two digits repeating, two digits in between, so you will get 9900 and 2484 minus 24, so you will get 2460. अच्छा, सेम ही हो जाएगा. So you'll have 12898989 repeat हो रहा है, so you'll get 9900 and 1289 minus 12 to 1277, right? अश्विनी, अमृता, अबीर और कौन कौन है उनमें? राजेश, सबको. हाँ बताओ, कुछ भी कर लो, कोई प्रॉब्लम नहीं, सेम आंसर आ रहा है, सेम आएगा. इन्फाइनेटली मेनी टाइम्स रिपीट हो रहा है, 4848 रिपीट हो, 8484 रिपीट हो. let us see like this, x is equal to 0.2484848 and so on. So I multiplied by, let us say 10 first, I'll get 2.484848 and alternatively I multiplied by, पहले तो 10 से ही करेंगे. Now I can either multiply this by 10 नहीं, कितने से करना था? अच्छा, ये इसको ये करना था या फिर 100 को मल्टीप्लाई करके देखना था, तो फिर 24.848484 ये आ रहा है ना. ठीक है, अल्टीमेटली तो कैंसिल ही होना है दोनों को. व्हेन आई मल्टीप्लाई एंड सबट्रैक्ट, दोनों भी रिपीटेड पार्ट विल गेट कैंसल. Why it doesn't matter is I can further multiply it by 10. 1000 x is equal to 248.484848. Still I'll get the repeated part. I can again multiply by 10,000 and I'll get 2484.8484. क्या कर रहा हूं मैं? 10 से मल्टीप्लाई कर रहा हूं. I'm multiplying on the both sides by 10. ऑफ कोर्स नंबर वोंट चेंज, दोनों साइड 10 से ही तो मल्टीप्लाई कर रहा हूं, कैसे चेंज होगा नंबर? होगा ही नहीं, किसी केस में नहीं होगा. हम पर्टिकुलरली 10 से 100 से क्यों मल्टीप्लाई कर रहे हैं? बिकॉज वी वांट टू गेट सेम डिजिट्स आफ्टर द डेसिमल पॉइंट, ताकि हमें सबट्रैक्ट करके सेम फ्रैक्शन मिले. वैल्यू चेंज नहीं हो रही, किसी से भी मल्टीप्लाई कर लो. हमें कैंसिल कराना चाहते हैं और फ्रैक्शन में कन्वर्ट कराना चाहते हैं, इसलिए हम 100 से 10 से वगैरह मल्टीप्लाई कर रहे हैं. बाकी तुम किसी भी नंबर से मल्टीप्लाई करो, वैल्यू थोड़ी चेंज होगी. दोनों साइड जो सेम नंबर है तो सेम ही है. तुम यहाँ पे 50 से मल्टीप्लाई करो, वहां पे भी करो, यहाँ पे 2.32 से करो, वहां पे भी 2.32 से करो, उससे कोई फर्क नहीं पड़ेगा. ओके, ये अबीर किसका आंसर है? ये 51234/9990. ये कुछ गलत आंसर दिया है तुमने. Let us look at our last case, then I'll take a recap of everything. what we have here now, we had 0 point something, now we have integral part as well. So number has non-zero number before decimal point, so integral part is non-zero, simple extension of earlier rule. तो 2.3333 ऐसा है, तो कुछ नहीं होगा, 23 माइनस 2 ऑलरेडी देख चुके हैं हम केस, 23 माइनस 2 डिवाइडेड बाय 1 बार 9, और ऐसा अगर है दैट देयर आर सम डिजिट्स इन बिटवीन, so we'll write the entire number and we subtract this entire thing 323 till till the repeated part from the numerator, and as many number of 9s as there are repeated digits, as many number of zeros as there are digits between decimal point and repetition. ये वर्किंग रूल है, बाकी सेम रहेगा, पुराना चीज बदलेगा नहीं. दैट बेसिक थिंग दैट वी वर ट्राइंग टू डू would remain the exactly the same. So for example, if I have this x is equal to 3.2343 bar, what will I do first? I will try to get repeated part start immediately after the decimal point. So for that I'll multiply by 100, है ना, ताकि repeated part immediately decimal के बाद चालू हो जाए. That is my step number 1. I'll get 323.43 bar. अब मैं जैसे चाहता था वैसे आ गया. नाउ आई कैन अगेन मल्टीप्लाई बाय 100 सो दैट रिपीटेड पार्ट सेम हो जाए डेसिमल के बाद, एंड आई कैन सब्ट्रैक्ट. सो आई विल गेट 10,000 इज इक्वल टू 32343.43 बार. अब मैं सब्ट्रैक्ट करता हूं, डिनोमिनेटर में क्या आएगा, 9900 आएगा, न्यूमरेटर में क्या आएगा, 32343 माइनस 323 जो यहां पे आ रहा है, आंसर सेम ही आएगा. This basic method works everywhere in all the cases. You can remember one thing and be done with it, or you can remember the working rule for faster calculations. Your call. समझ गया, right? This is the final case. So if I have to recap, if we have to recap everything, what we were trying to do, what we were trying to do, we were trying to convert our given decimal number into fraction, right? For terminating fractions there was no issue. टर्मिनेटिंग के लिए तो बस रिलेवेंट पावर ऑफ 10 से मल्टीप्लाई न्यूमरेटर और डिनोमिनेटर में कर दो, बात खत्म, राइट? बट प्रॉब्लम वाज विथ नॉन टर्मिनेटिंग वंस. So for non-terminating words, what we tried to do is we tried to firstly write non-terminating ones in the form of bar. So whatever, if we have 3, we wrote 3 bar. If we have 0.12, then 12 bar. And for each of the cases, we deal with differently. The basic case was that when decimal point starts immediately after the decimal point, recurring starts immediately after the decimal point, like here. There is no gap between recurring and the decimal point, like for example in these cases. There is no non-recurring digit occurring between decimal point and the recurring part. That was our most basic case which we dealt with initially, and later what we tried to do, we tried to convert our all other cases that we were facing into this particular case for ease or simplicity. And in this particular case, what we did, we firstly considered a fractional number such that integral part is 0. So for such cases, we simply multiply by relevant power of 10, which is basically number of repeated digits. एक है तो 10 से मल्टीप्लाई करेंगे, 2 है सर 100 से करेंगे, 3 रिपीटेड डिजिट्स है तो 1000 से करेंगे, एंड सो ऑन, सो दैट नंबर्स और दैट आर ऑकरिंग आफ्टर डेसिमल पॉइंट, आफ्टर मल्टीप्लिकेशन एंड बिफोर मल्टीप्लिकेशन शुड बी सेम. क्योंकि जब मैं दोनों को सब्ट्रैक्ट करूंगा तो मैं कैंसिल कराना चाहता था दोनों को. When I subtract, if all the digits after decimal points are same in both the numbers, then I get rid of the recurring, infinitely many times recurring number which I had problem with. अब तो मुझे बस इंटीजर माइनस इंटीजर मिलेगा तो मैं कर लूंगा. That was the first case. When we multiply this 0.12 by 100, I'll get 100x is equal to 12 bar 12.12 bar so that this 1 2 bar is common and I subtract, so I get rid of this. So I'll simply get 12 by this 100x minus x, so 99x. So 12 by 99 was the answer. And working rule for this particular case was very easy. If you have 0 point, any number of points, any number that is recurring and 0 के बाद ही recurring start हो रहा है, तो जो भी है उसको लिख के that many number of ninth was my answer. That was the simplest of the working rule. उतनी बार 999 लिख दो और बात खत्म. Then we considered integral part and recurring starts now immediately after the decimal point. Just change क्या था, यहाँ पे recurring part, sorry, यहाँ पे integral part भी है, बाकी सेम ही है. Method यहाँ पे भी सेम था. I multiply by relevant power of 10 so that I get again recurring part after decimal point same as this. So I multiply by 100, तो मेरे को मिलेगा 183.83 बार. And then I subtract 100x minus x, so 99x is equal to 182 आएगा. And 182 by 99 was my answer. Working rule would be, we forget that there is any recurring or decimal point. I take it entire number as 183, subtract this integral part, so I get 182, and in denominator, as many number of digits are recurring, I write that many number of nines. This was the working rule. Then next was that recurring will start after some time. For example, this 1 2 and then recurring starts for 3 4 bar. In this case, we try to convert this case into the cases we know. We don't know how to deal with this, but what we know, if you multiply it by 100, you will get recurring immediately after the decimal point. This I know how to handle with. So I convert my x into the number I am comfortable with, such that recurring starts immediately after decimal point by multiplying whatever relevant power of 10 that I can. Now इसको अब मैं convert कर सकता हूँ fraction में easily, क्योंकि मुझे पता है, working rule भी पता है, otherwise भी मैं कर सकता हूँ. Otherwise भी मैं इसको 100x को 100 से multiply करूँगा, so I'll get the same part, same fractional part in both the numbers and I can subtract. Otherwise also working rule होगा 1 2 3 4, पूरा नंबर विदाउट डेसिमल कंसिडर करके उसमें से 12 सब्ट्रैक्ट करना है मुझे, तो मिलेगा 1 2 2 2, और जितने भी बार जितने भी डिजिट्स रिपीट हो रहे हैं उतना बार 9 लिखना है मुझे. तो देयर आर 2 डिजिट्स दैट आर रिकरिंग, so I'll write 2 times 9. That was this case. And the final case, if I have something like integral part भी है 51 point, let us say 0 1 2 and then repeating, ऐसा कुछ है, then again चीज सेम ही है. I'll convert this into something I am comfortable with. I multiply by 1000 and get repetition immediately after the decimal point, and now I know how to work with this, right? ठीक है, समझ में आ गया पूरा पूरा समझ में आ गया. All the working rules and all the basic methods, whatever you are trying to do. हाँ, ट्रिपल नहीं, 2 बार ही है ना, 2 ही डिजिट रिपीट हो रहे हैं. बट हियर वी हैव 1000x, वो अल्टीमेटली 1000 से डिवाइड भी होगा ना, तो 99000 आएगा. तो यहां से भी तुम वर्किंग रूल भी उसका वैसा ही है, हाउएवर नंबर ऑफ डिजिट्स दैट आर देयर, उतने बार 9, जितने डिजिट्स इनके बीच में है उतने बार 0, और फिर पूरा नंबर माइनस ये वाला नंबर. यही उसका वर्किंग रूल है. Now solve these 5 questions and this CSE 2020 question. You have 5 minutes. 5 questions and this 6th question. हो गया? डन डन, गुड. फर्स्ट क्या है आंसर? 1 2 ऐसा सबका यही आ रहा है. ये भी आंसर है ना, 1111 डिवाइडेड बाय 900. इक्विवेलेंट है दोनों, टेंशन मत लो. यू रेट दिस एज 1 2 3 4 बार ना, 1.23 बार. 4 ही रिपीट ले रहे हो तुम, 44 रिपीट ले रहे हो. इट्स इक्विवेलेंट. यू कैन डिवाइड दिस नंबर बाय 9 शायद. नहीं, यू कैन डिवाइड दिस नंबर बाय 11 एंड यू विल गेट द सेम. ठीक है, दोनों इक्विवेलेंट है. सेकंड, you this is 2.123 bar. What is this equal to? ये है, यही है ना? क्या गलत हो गया? सही है. Then this ये है, राइट? हाँ, 44.4 बार है ये. 444 minus 44 divided by 9. This is 1.1112 bar, which is equal to 11112 minus 1111 divided by 9000. ये है आंसर. जो भी आएगा ये आएगा. दिस इज 10001 and 9999000. Yes, that is correct. सही है. लास्ट 6.00012 बार इज इक्वल टू डिनोमिनेटर में आएगा 99000. न्यूमरेटर में क्या आएगा? अच्छा, 2 ही है, सॉरी, मैंने 3 लिखा ना इधर, इसलिए. क्या आएगा? 60006 हाँ, ये नंबर -6 होगा ना। -600, सॉरी, 60012 -600 ये होगा। So you will be 59412. Yes, that is correct. 59412 by 9900. वर्किंग रूल में ऐसी गलतियां हो सकती है, बेसिक मेथड में नहीं होगी। उसमें डायरेक्टली दोनों साइड साथ में मल्टीप्लाई करते हो ना, उसमें नहीं होगी गलतियां। एंड पीवाईक्यू सॉल्व किया सबने? व्हाट इज दिस, ऐसे बता दो। 127 - 1, तो 126 divided by 99. Yes, that is not in the options as it is. ऑप्शन में नहीं है, you have to reduce it. 9 से डिविजिबल है दोनों, डिवाइड बाय 9 न्यूमरेटर एंड डिनोमिनेटर and you will get the answer. 14 9s are 126 and 11 9s are 99. We will have 14 by 11 as the answer. Yes, very easy question. अब PYQ है, वो भी एकदम बेसिक केस वाला पूछा है, कोई ज्यादा डिफिकल्ट नहीं दिया। रिपीटेशन स्टार्ट्स इमीडिएटली वाला ही केस पूछा है ना। Then last thing, now we want to learn how to operate on fractions. Operate मतलब जो हमारे बेसिक मैथमेटिकल ऑपरेशंस है, एडिशन, सब्ट्रैक्शन, डिवीजन एंड मल्टीप्लिकेशन एंड पावर्स एंड बॉडमास, ये सारे रूल्स, हाउ डू वी अप्लाई देम टू फ्रैक्शंस? एग्जैक्टली सेम, एक्सेप्ट एडिशन, मल्टीप्लिकेशन, सब्ट्रैक्शन, डिवीजन अलग तरीके से होता है। एडिशन ऑफ टू फ्रैक्शंस, वहां से स्टार्ट करेंगे। केस इज डिनोमिनेटर ऑफ बोथ द फ्रैक्शंस इज सेम। इफ डिनोमिनेटर ऑफ बोथ द फ्रैक्शंस इज सेम, देन विल जस्ट ऐड द न्यूमरेटर, डिनोमिनेटर एज इट इज रहता है, एंड वी गेट द फ्रैक्शन एडिशन। फॉर एग्जांपल 5/7 plus 6/7, 1/7 is 5 plus 1/7, which is 6/7. If denominator is same, we can just add the numerator, and addition of the numerator divided by the same denominator is our addition of two fractions. ठीक है? If there are 7 things, I have 5 things and I add to it 1 thing, that is what we are doing. 5 out of 7 plus 1 out of 7, so in together I have 6 out of 7 things. Another case, 12/4 plus 3/4, because denominator is same, I'll just add the numerator, I'll get 15/4, which I can also write it as 3 complete and 3/4 more. 2/7 plus 3/7 plus 5/7, again denominator is same, I can add numerator of all the 3 numbers, 2 plus 3 5, 5 plus 5 10/7 would be my answer. And of course I can write it as 1 complete and remainder is 3/7. I can write it is like this. पता है ना नोटेशन? How do I write? This is our quotient, this is our remainder, and this is our divisor. ऐसे लिखा जाता है. So what is the this is dividend. Dividend is divisor into quotient plus remainder. 7 plus 1 plus 7 plus 1, 7 into 1 plus 3. So you will get 10, and by divisor, that is 7 there in the denominator. Now case 2, if denominator is not same, in this case what we do is we make denominator same by multiplying both the fractions by relevant number. in the numerator as well as in the denominator. Why can we do that? Because we recall that value of fractions do not change when we multiply it by multiply and divide numerator and denominator by same number. For example, if I have this 2 by 3, I can multiply both 2 and 3 by same number and value of fraction will not change. I can multiply both by, let us say, 4. I'll get 8 by 12. Value of both the things is same. Or I can divide now this 8 by 12 by, let us say, 2. I'll get 4 by 6. Value of them is same. I can divide or multiply both numerator and denominator by same number and value of fraction will not change. Right? That is why we can manipulate our fraction such that denominator of both the fractions that we are supposed to add becomes same. So if I have to add 2 by 3 plus, let us say, 1 by 2. What I try to do is, I try to make their denominator same. So I can make this denominator as 3, I can make as 6, I can make as 9, I can make as 12, and 2 I can make as 4 by multiplication. 4, 6. So both the denominators I can make as 6. So I make as 6. So this is equal to 2 by 3 becomes, if I want to make this 6, I multiply both numerator and denominator by 2. It becomes 4 by 6 and this becomes 3 by 6. So I'll have 7 by 6 as my addition. Right? This is how we add. If you don't have same denominator, we make the same denominator. Basic idea समझ गए ना. How do you make in actual calculation वो अभी देखेंगे. यहाँ पे तो बहुत इजी था, 6 था दोनों का, वो तो दिख रहा था सामने कि दोनों 6 बन सकते हैं, बट मेनी टाइम्स नहीं दिखेगा. फॉर एग्जाम्पल लेट अस से दिस 7 by 11 प्लस 9 by 13, या फिर 9 by, चलो कुछ और ले लो, 6 ले लो, थोड़ा सा इजी. ठीक है. नाउ बाकी कुछ हो ना हो, डिनोमिनेटर कैन ऑलवेज बी मेड मल्टीप्लीकेशन ऑफ दीज टू थिंग्स. मतलब ये 11 and 6 को मल्टीप्लाई करूंगा तो आई विल गेट 66. तो 66 वुड ऑफ कोर्स बी अ कॉमन मल्टीपल ऑफ 11 and 6. दोनों भी वो बन सकते हैं अगर 11 नंबर से मल्टीप्लाई करो तो. मल्टीप्लीकेशन ऑफ दीज टू नंबर्स इज डेफिनेटली अ कॉमन मल्टीपल. लीस्ट है कि नहीं पता नहीं, बट कॉमन मल्टीपल तो पक्का है. अभी तो मुझे ऐड करने के लिए बस डिनोमिनेटर सेम चाहिए, एलसीएम चाहिए, ऐसा कोई वो नहीं है. आई जस्ट नीड कॉमन डिनोमिनेटर एंड इजिएस्ट वे टू फाइंड द कॉमन डिनोमिनेटर इज वी नो दैट मल्टीप्लीकेशन ऑफ दीज टू नंबर इज अ कॉमन मल्टीपल. 11 into 6 66 अगर मैं करूं, बिकॉज इट इज 11 into 6, ये 11 के टेबल में भी आता है, 6 के टेबल में भी आता है, बस मल्टीप्लाई तो किया है मैंने, ऑफकोर्स आएगा. समझ रहे हो? So if I want to make this denominator as 66, I multiply both by 6, which is nothing but this number. So I have 7 into 6 plus 11 into 9 divided by 11 into 6. This is my addition. This is the addition of two fractions. हाँ, 2 by 3 plus 3 by 4. I can make the denominator as 4 into 3 12. 12 तो बन ही सकता है डिनोमिनेटर. यही क्या है? For making this 3 into 12, I multiply by 4, 4 4. For making this 4 into 3, I multiply by 3, and 8 by 12 plus 9 by 12, I get 7 by 17 by 12. Or the method which we saw, multiply this numerator by this denominator, multiply this numerator by this denominator, and then their multiplication in the denominator. 4 into 2 plus 3 into 3 divided by 3 into 4. कर वही चीज रहे, we are making the denominator same and we are adding the numerator. कर वही चीज रहे. Note, in making denominators equal, we are essentially finding a common multiple of denominators. Product of two numbers will always be their common multiple, as we have seen. बट वी हैव स्टडीड एनीथिंग एल्स इन्वॉल्विंग कॉमन मल्टीपल. देखा है हमने कुछ कॉमन मल्टीपल का? लीस्ट कॉमन मल्टीपल हमने देखा है लास्ट सेक्शन में. सो वी कैन convert the denominators into LCM as well. LCM also be their common multiple na. We can either convert the denominators into LCM and then add, or we can just straight away multiply and then add. Straight away multiplication can be difficult if numbers are bigger. वहां पे LCM निकालना थोड़ी जरूरत हो जाए. But if not, we can directly add using taking by directly multiplying. वो भी कर सकते हैं. देखो, फॉर एग्जाम्पल अगेन 3 by 80 plus 5 by 16. What we do? 3 into 16 plus 5 into 80 divided by 80 into 16. 40 plus 400 divided by this. तो इसको रिड्यूस करोगे तो you will get 7 by 20. This 80 into 16 करना पड़ेगा, 16 into 3, 80 into 5 इनको ऐड करना पड़ेगा. सो बिगर नंबर हो सकते हैं इफ यू जस्ट ब्लाइंडली फॉलो दिस मेथड कि हाँ सीधा मल्टीप्लाई करना है. बट इफ यू रिकॉल दैट 80 तो 16 का मल्टीपल है ही, 16 5 से 80, यू कैन जस्ट मेक दिस डिनोमिनेटर 80. एलसीएम है ना 80 दोनों का. यू कैन जस्ट मेक दिस डिनोमिनेटर 80 by multiplying by 5 and you will get 3 by 80 plus 25 by 80, 28 by 80, 7 by 20. So you can try to reduce your calculation burden as well. If you don't want to, you can directly multiply. Now let us add few numbers. Tell me addition 7 by 2 by 7 plus 3 by what can you say 10. What is it? 10 into 2 20 plus 21, 7 into 3, so 41 divided by 70. Multiplication of these two numbers, this plus this upon this. 1 by 3 plus 17 by 19. 19 into 1 plus 17 into 3, 51. 51 plus 19, 70 divided by 19 into 3, 57. ठीक है. This plus this divided by this. One more. कैसे करोगे? ये मल्टीप्लाई करना है. हाँ, note that LCM of these two is 320 only. So you can multiply this by 4. You'll simply get 284 by 320 plus 60 by 320, and now we can directly add. So you will have 344 by 320. यहाँ पे मल्टीप्लाई करने जाएंगे तो 10 मिनट चले जाएंगे, है ना. So if LCM is clearly visible or is very easy to calculate, तो LCM करके कर सकते हो. And if numbers are very small either way, तो सीधा मल्टीप्लाई कर सकते हो, सोचने की जरूरत है नहीं. If numbers are larger, then only think about LCM or something like that. If numbers are small enough for you to operate, then directly कर लो, फटाफट बिना सोचे चल जाएगा. Answer would be same, may be reduce करना पड़े थोड़ा for getting the answer that is there in the options, वो हो सकता है. ठीक है, एडिशन नो प्रॉब्लम. यही लिखा है. नाउ दिस इज एक्सरसाइज. कितना टाइम लगेगा या घर पे करोगे? होमवर्क करना है या भी करना है? होमवर्क करते नहीं हो तुम लोग ना. हाँ, एक एक बंदा नहीं करके ला रहा है यार होमवर्क। कितना ही टाइम लगता है HCFL से? एक एक मिनट का एक सवाल होता है। 10 सवाल दिए थे मैंने, हार्डली 10 मिनट तुम्हें निकालने थे। इसके बाद सब्ट्रैक्शन है, मल्टीप्लिकेशन है, डिवीजन है एंड पावर्स है। दैट इज ऑल। ये शायद लास्ट ही है, फिर बॉड मास है। करोगे वो फिर घर पे? हाँ, कल का क्या है? कल आ रहे हो ना? क्यों? अरे तो अभी तो आ रहे हो तो आ जाओ। क्या प्रॉब्लम है कुछ? कल तो दिवाली है नहीं, देखो तो दिवाली तो मत बोलो। परसों है ना दिवाली। कल क्या है फिर? इफ यू आर नॉट गोइंग होम देन व्हाट इज द इशू? रीजन बता रहा हूँ, बिकॉज नेक्स्ट वीक के बाद मुझे थोड़ा सा प्रॉब्लम होगा। मेरा 26 से फॉरेस्ट है, तो आई कैन नॉट टेक लेक्चर्स इन दैट वीक और द नेक्स्ट वीक, क्योंकि 2 तारीख वाला जो वीकेंड है वहाँ तब तक एग्जाम है। तो आई हैव टू फोर्सफुली गिव यू ऑफ दैट टाइम। फालतू में अपना 2 वीक 3 वीक खींचेगा, उससे अच्छा अभी कर लेते हैं जितना कवर कर सकते हैं। अननेसेसरी की छुट्टी क्यों चाहिए? इफ यू आर अवेलेबल, कम ना। दोज हु कैन do, those who are home, they can watch online. कल लेक्चर है, संडे इज ऑफ बिकॉज क्लास ही बंद है, मैं कुछ नहीं कर सकता उसमें। बट टुमारो वी हैव अ लेक्चर। फाइन, लेट अस डील विथ सब्ट्रैक्शन ऑफ फ्रैक्शन। सेम, एग्जैक्टली सेम एज एडिशन, कोई चेंज नहीं। There we were making the denominator same and adding the numerator. Here we'll make the denominator same and subtract the numerator. Exactly same. So 5 by 12 minus 3 by 12, 5 minus 3, 2 by 12 is equal to 1 by 6. 4 by 7 minus 4, 6 by 7, 4 minus 6 is minus 2 by 7. Numerator 1 minus numerator 2 divided by common denominator. इफ डिनोमिनेटर इज कॉमन, डायरेक्टली सब्ट्रैक्ट कर देंगे, अगर नहीं है तो डिनोमिनेटर को कॉमन बना के सब्ट्रैक्ट कर देंगे। बात वही है। लेट अस सी दिस 3 एग्जांपल्स। सॉल्व करो तुम भी। 6 by 7 minus 2 by 3, जैसे एडिशन में किया था वैसे ही करना है। 6 into 3 18 minus 7 into 2 14, 6 into 3 minus 7 into 2 divided by 7 into 3. Same process, numerator 1 into denominator 2 minus numerator 2 into denominator 1 divided by multiplication of both the denominators. Exactly same है process. Here also, because multiplication would lead to larger numbers, we observe that 16 and 80 का LCM 80 ही है. We just multiply this fraction, numerator and denominator both by 5 to make the denominator same. So we'll get 25 by 80 minus 3 by 80, so 22 by 80, and then we can write it as 11 by 40. ठीक है? फ्रैक्शंस निगेटिव में भी आ सकते हैं, क्योंकि सब्ट्रैक्शन है, निगेटिव में जा ही सकता है, कोई उसमें वो नहीं है। एंड दिस निगेटिव साइन we can write this as minus 16 by 35. We can also write it as 16 by minus 35. We can also write it as minus of 16 by 35. All of them are equivalent. माइनस साइन कहीं पे भी डाल दो एक जगह पे, इट इज सेम, कोई फर्क नहीं पड़ता। बिकॉज अगेन वी कैन मल्टीप्लाई एंड डिवाइड बाय -1 और माइनस साइन शिफ्ट हो जाएगी। अगर ये minus 16 by 35 है एंड आई मल्टीप्लाई एंड मल्टीप्लाई न्यूमरेटर एंड डिनोमिनेटर बाय -1, तो क्या हो जाएगा? minus 16 into -1 divided by 35 into -1. So numerator will become minus minus plus. We'll have 16 into and plus minus minus, so minus 35. तो ऊपर हो नीचे हो सब सेम है, because we can always multiply by -1 and sign will change from numerator to denominator. सब सेम। ठीक है, मतलब सब्ट्रैक्शन कुछ नया नहीं है, सेम थिंग विच वी डिड इन एडिशन, एग्जैक्टली सेम है, नो चेंज. मल्टीप्लीकेशन इज डिफरेंट बट सबसे इजी. मल्टीप्लीकेशन इज जस्ट डायरेक्ट मल्टीप्लीकेशन, so a into c and b into d. Multiply the numerators, multiply the denominators, and you will get the multiplication of two fractions. 3 by 4 into 4 by 5 is 12 by 20, which is 3 by 5. We can multiply directly. We can have 7 by 6 into 8 by 7. So you will get direct multiplication. Either you can do 8 into 7, 56 by 6 into 7, 42, and then reduce, or you can see straight away cut it and then write the multiplication. 3 by 4 into 5 by 7 is equal to 3 into 5, 15 by 7 into 4, 28. Multiplication is easy. Multiplication सीधा numerator divided by denominator. That is the multiplication. ठीक है, straight away multiply करना है जैसे का तैसा. And multiplication में you can cut these things. You can again divide by, let us say 2, so you will have 4 by 3. ऐसे कर सकते हो. If multiplication division only are involved, so all of this is single term. Within single term you can cut, you can divide by same number, you can multiply by same number, whatever you would like to do. देखो minus 3 by 4 into 2 by 5, 3 into 2 6, 4 into 5 20, and minus plus minus, right? And minus sign you can put anywhere, you can put outside, you can put at -1, you can put at -20, anywhere you can put minus sign, that does not change the value. And here also 3 by 4 into 4 by 5, you can either multiply 12 by 20 and then reduce, or you can straight away cut this 4 and write the answer as 3 by 5. Rules for multiplication, of course same, minus into minus, plus into minus, or minus into plus would be minus, and plus into plus is plus. Positive positive positive, positive negative, or negative positive will give negative, and negative into negative is positive. Old rules जो हमने इंटीजर्स के लिए पढ़े थे, they stay here, they are valid. ठीक है, चले आगे. हाँ हाँ, निगेटिव वो होगा रे, नहीं, इज इक्वल टू पॉजिटिव इंटू निगेटिव इज इक्वल टू निगेटिव. हाँ, दोनों एक साथ लिखा है, negative into positive or positive into negative, which is negative. Division is nothing but reverse of multiplication. Dividing by any number is multiplying by its inverse. So if you are dividing by c by d, for example, if I have this a by b and I divide it by, let us say, n. If I want to do this, it is equivalent to multiplication by inverse of n. Multiplication तो पता है हमें, which is a by b n. Straight away multiply. Similarly, if I have a by b divided by c by d, then it is equal to multiplication by inverse of this, which is 1 by c by d, which is a by b into d by c. Multiplication by inverse, उल्टा करना है इसको, which is ad by b, right? Division is nothing but inverse of multiplication. a by b ये हमने किया, और a by b by c by d, a by b divided by c by d को ऐसे भी लिख सकते हैं. This division ही होता है when we write fraction, that is nothing but division. So a by b by c by d is equal to उल्टा multiplication a by b into d by c, and then we can multiply. Examples है 5 by 6 divided by 2 by 3 which will be nothing but 5 by 6 into 3 by 2. Same thing with fraction. 3 by 4 divided by 2 by 3 is equal to 3 by 4 into 3 by 2. उल्टा करके multiply. Let me give you some questions. Addition के तो उधर पड़े हुए हैं. Addition are there ना. Divide these numbers. हो गया? हो गया? फर्स्ट का क्या है? नथिंग बट 5 by 7 into 7 by 1. 7 कट जाएगा, आंसर वुड बी 5. Second, this is firstly if you do this you will get 3 1s are 1, 3 2s are this. So 1 by 2 divided by 2 is equal to 1 by 2 into 1 by 2 1 by 4. सही है? गलती की किसी ने? सही है ना? नेक्स्ट, फर्स्ट पहले दो को करो. 4 by 2 divided by 2 is 2. 4 divided by 2 divided by 1 by 2 is equal to 2 into 2. उसका उल्टा, when you want to convert division into multiplication, उल्टा करके करना पड़ता है. And this 1, you have 5 by 19. If you convert this into multiplication into 19 by 2 and divided by 5 by 2 है ना. So 5 by 2 divided by 5 by 2 nothing but 1. कोई दिक्कत नहीं है, मैं तो सेम नंबर डिवाइडेड बाय सेम नंबर 1 ही होता है इसलिए मैंने लिख दिया. ए डिवाइडेड बाय ए क्या होता है? 1 होता है हमेशा. हाँ हाँ लगा दो, कोई बात नहीं. इंटू 2 by 5. तो 5 5 2 2 आंसर 1. कंफ्यूजन ना हो इसलिए एक स्टेप ऐड कर दिया. ठीक है? एडिशन सब्ट्रैक्शन मल्टीप्लिकेशन डिवीजन कर सकते हो, कोई प्रॉब्लम नहीं है. पक्का? नेक्स्ट इज पावर्स, जो हमने इंटीजर्स के लिए किया था. वी हैव स्टडीड एवरीथिंग, हम सब पढ़ चुके हैं. जस्ट अब फ्रैक्शन के लिए स्पेसिफिक केस में पढ़ रहे हैं. कोई चेंज है नहीं. एडिशन सब्ट्रैक्शन अलग है क्योंकि डिनोमिनेटर सेम करना पड़ता है, बट अदर देन देयर इज एब्सोल्युटली नो चेंज. All the same rules will apply to fractions as well, of addition, of multiplication, subtraction, powers, everything is same. Power के लिए बस definition पढ़ना है, बाकी all the rules are same, exactly same. Numerator by denominator raised to a. So for example, if I have any a by b raised to n, ये क्या होगा? It is nothing but a raised to n by b raised to n. That is the definition, how the power distributes between numerator and denominator. Everything else, all the properties that we have studied are same as what we have studied for integers. Exactly same. For example, let us look at this. Now we have same base. पावर चेंज नहीं कर रहे, a by b है तो a by b ही है हर जगह पे. a by b raised to m into a by b raised to n, what would it be? Add हो जाता है पावर. When we are multiplying two powers, recall this, a raised to m into a raised to n क्या होता था? a raised to m plus n. So instead of a we have a by b, बाकी कुछ चेंज नहीं है. Exactly same. And ये फिर definition के accordingly it will be distributed in the numerator and denominator both. So it will be a raised to m plus n divided by b raised to m plus n. Other than that there is no change. Same with division. Recall a raised to m divided by a raised to n क्या होता था? a raised to m minus n. Same is the story here. Exactly same. Right? Next, a by b raised to 0. Any power, any number raised to 0 is 1 always. पहले भी यही होता था. a raised to 0 is equal to 1. And this is true for all the fractions as well. Okay? a by b raised to 1. Anything raised to 1 is itself. First power मतलब वही number. a raised to 1. ये भी हमने पहले पढ़ा था, a raised to 1 is a for all the integers. Similarly, a by b raised to 1 is a by b. Next, a by b inverse is 1 upon a by b. ये भी पहले पढ़ा था. a raised to minus 1 is equal to 1 by a. Same thing, a by b raised to minus 1 is 1 by a by b, which is nothing but b by a. उल्टा हो जाता है ना. This is b by a. Next, a by b raised to minus n क्या होगा? 1 upon a by b raised to n होगा. So it would be b by a raised to n, which is nothing but b raised to n by a raised to n by definition. ठीक है? Next, a by b raised to m to the power bracket to the power n. ये भी हमने पहले पढ़ा था. a by b raised to m is equal to a by b raised to mn. a raised to n क्या होता था? a raised to mn होता था. Same rule applies here as well. Absolutely no change. Next, multiplication. ये भी हमने पहले पढ़ा था. a into b raised to n क्या होता था पहले? a raised to n b raised to n होता था. Same thing. If we have two different fractions and we are multiplying them and taking their powers, so power just distributes it between both of them. दोनों का पावर सेम होगा. n दोनों जगह पे जाएगा. Then we take power. And all of these rules follow from definition of powers. Power is nothing but repeated multiplication. a by b to the power n का मतलब क्या है? Nothing but a by b into a by b into ऐसे n times. From this everything follows. सारे रूल्स फॉलो फ्रॉम दिस वन सिंपल फैक्ट और डेफिनेशन. ए कितनी बार मल्टीप्लाई होगा? n बार होगा, वो n बार होगा. एंड b कितनी बार होगा? वो भी n बार होगा, बिकॉज मल्टीप्लाई कर रहे हैं. तो ये वहां से फॉलो हो जाता है एंड फ्रॉम दैट ऑल द रेस्ट फॉलो. ठीक है? देयर इज नथिंग न्यू कंपेयर टू व्हाट वी स्टडीड इन इंटीजर्स. सो गो थ्रू दिस rules. I hope you can recall all these rules whenever you want. Whenever you are solving question, ये सारे rules you will be able to use. Worksheet solve करिए तुमने? You guys have solved the worksheet or not? Now you can solve the worksheets. Now we have completed this booklet. आपको booklet नहीं मिली होगी ना? नहीं लिया है. You can take from outside और बाहर होगी तो बाहर से ले लेना, वरना ऊपर से लेनी पड़ेगी. Lastly, last rule, we have studied this as well. A by b raised to m by n is nothing but mth power or nth root. mth power or nth root. ये पढ़ा था हमने, ये भी, that a raised to m by n is equal to nth root of a raised to m. वही है. Just instead of a, we have a by b there. Exactly, rest of the things are same. ठीक है. These are all the rules. Go through them, go through those rules, and I need you guys to solve these questions based on all the rules that we have studied. अगर सब कुछ सही आ जाता है, then you can be assured that ठीक है, हो गया, मतलब इससे ज्यादा कुछ नहीं होगा. बॉड मास फॉर फ्रैक्शन, बॉड मास हमने 2-3 दिन पहले ही पढ़ा था, 2 क्लासेस पहले. एग्जैक्टली सेम है. देयर इज एब्सोल्युटली नो डिफरेंस बिटवीन बॉड मास फॉर इंटीजर्स एंड बॉड मास फॉर फ्रैक्शन. एग्जैक्टली सेम है. जस्ट मल्टीप्लीकेशन होगा तो फ्रैक्शन का मल्टीप्लीकेशन होगा, एडिशन होगा तो फ्रैक्शन का एडिशन होगा, सब्ट्रैक्शन होगा तो फ्रैक्शन का होगा, पावर होगा तो फ्रैक्शन का होगा. अदर देन दैट एब्सोल्युटली नो चेंज बिटवीन बॉड मास ऑफ इंटीजर्स and bod mass of fractions. No change at all. Bod mass stands for bracket, order, then division, multiplication, then addition, subtraction. It refers to the order in which you have to perform the operations when we are given a long expression having multiple terms. This refers to order in which you have to perform those operations. और यह order bod mass से दिखाया जाता है. ये ट्राई करना है अभी या कंप्लीट करना है बुकलेट? ये घर पे करोगे? मुझे तुमसे ट्रस्ट ही नहीं आ रहा. घर पे करोगे वाले? हाँ, करवाना पड़ रहा है तुमसे. बोथ और एडिशन प्रॉब्लम्स और ये सब्ट्रैक्शन के नहीं है ना, सब्ट्रैक्शन प्रॉब्लम्स भी देने पड़ेंगे. सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन के तो 4-5 कर लिया अभी. मल्टीप्लिकेशन तो इज नॉट चैलेंजिंग. मल्टीप्लिकेशन के क्या ही प्रॉब्लम करने. You just have to multiply numerator by numerator and denominator by denominator. उसमें कुछ सॉल्व करने लायक नहीं है अलग से, to get acquainted. But addition you should solve. और एडिशन कर लिया तो सब्ट्रैक्शन भी कर लिया, क्योंकि सेम ही तो प्रोसेस है. ऐड करने की जगह सब्ट्रैक्ट करना है, कुछ डिफरेंट तो है नहीं. But these are different problems, power problems. These are different because you have to use all those rules. That is why it can be a bit challenging. एडिशन कर लेना घर पे. Solve this right now. And then next last one section we can do tomorrow, and we'll start the new booklet as well from tomorrow. कितने क्वेश्चन है? There are 7 questions. You'll need कितने minutes? 14 minutes? Less than that. Let us say you need 14 minutes. Solve them. Amrita, good. She has already solved. Please solve the worksheets. If you face any problem in any of the worksheet question, we can discuss it. Worksheet and its solutions are already uploaded. Solutions, I mean answers. Answer key has been uploaded, not the detailed solution. If you face any problem, yes, tomorrow we'll start. This is extension of arithmetic only, relative size of numbers. So when we have to compare which number is greater, which number is smaller, which of them are equal, that we'll do. Primarily we'll face challenge with respect to fractions and powers. So if you are given 2 random powers, how do we decide which is bigger or which is not? So this question was asked again. If I give you like 2 raised to 40 and 3 raised to 30, how will you decide which of them is bigger, which of them is smaller? That is what we'll study tomorrow, how to compare such powers. क्या हुआ? Hmm. Hmm. What is the best possible answer you can get? Please get that. So you can write this 6 as 2 into 3. तो ये 3 3 कहीं ना कहीं कैंसिल हो जाएंगे. वो कैंसिल करा करा के जो एकदम बेयर मिनिमम बचता है वो मुझे आंसर दे दो. हम्म. देखो what we have is 1 by 3 to the power 15 divided by 1 by 6 to the power 15, which is same as 1 by 3 divided by 1 by 6 to power 15. ठीक है. You can solve this in multiple ways. ऐसा नहीं है, कोई भी रूल डिफरेंट डिफरेंट अप्लाई कर सकते हो. दिस वाज द सिंपलेस्ट. यस. Abir, it is possible to do tomorrow's class without finishing previous lectures. We don't use knowledge of previous lectures that much, except for rules, how to deal with powers. The same rules that we have done for fractions, they will be important. Other than that, you can cover at your own pace, whatever we have covered till now. But ensure that you complete all those lectures, because arithmetic has been distinctly important in past 1 or 2 years. Many questions have been asked. Okay. दिस अरिथमेटिक वाला बुकलेट ही सबसे बड़ा था. बाद वाले अभी इतने बड़े नहीं होंगे. नाउ विल हैव स्मॉलर बुकलेट्स. तो इन जनरल मैक्सिमम 1 और 2 क्लासेस में एक बुकलेट खत्म हो ही जाएगा. तो विल नाउ कवर सिलेबस एट फास्टर रेट. अरिथमेटिक क्योंकि इतना बड़ा चैप्टर है एंड इट फॉर्म्स द बेस फॉर ऑल अदर चैप्टर्स. अगर इसमें कोई प्रॉब्लम है तो बाद के सारे ही चैप्टर्स में प्रॉब्लम होने लगती है. बट अगर इसमें पकड़ है तो बाद में कोई ज्यादा चैलेंज है नहीं. यस, नेक्स्ट कल तो ये हो जाएगा रिलेटिव साइज ऑफ नंबर्स. नेक्स्ट फ्राइडे विल कवर ज्योमेट्री, and next week we'll try to cover geometry and linear equations both, and the week after next lecture after that comprehension we can start. बट ओवरऑल देखा जाए तो कॉम्प्रिहेंशन में ज्यादा लोग को प्रॉब्लम है नहीं. ऑफ कोर्स विल प्रैक्टिस एंड यू शुड इंक्रीज योर रीडिंग स्पीड, बट फ्रॉम व्हाट आई गैदर not lot of people have problem with comprehension like they do in mathematics, है ना. Most of you are here for maths, comprehension कर लेते हो. Of course not that well, of course we have to work on that, वरना तो सब सारे 27 सही हो जाते तो यहाँ तो आराम से क्वालिफाई कर लेते. in towards this month end हम कुछ lectures मिस करेंगे. We can take extra lecture next month as per your convenience. ज़्यादा से ज़्यादा लोग जब available होंगे we can take extra lectures, and if you guys want syllabus जल्दी खत्म हो जाए, like instead of February we complete everything in January, तो we can keep taking extra classes, no issue. तो आपका कॉल है जब कब खत्म कराना है. Otherwise by February we'll definitely cover towards February. तब भी आपको 3 महीने बचते हैं प्री के लिए, तो इतना वो बहुत वो नहीं है कि हाँ जल्दी जल्दी करना है. बट इफ यू वांट वी कैन फिनिश अर्ली एज वेल, बट अगेन एक्स्ट्रा लेक्चर लगेंगे. फिर ये हो गया सारे नहीं. ओके, व्हाट इज दिस आंसर, फाइनल आंसर. बेस सेम है, same base, then we can just add the powers, which is nothing but a by b to the power 9 plus again 9p by q plus 9p by q, 5p by q plus 9p by q. So again denominator is same, addition of numerator 9 plus 5 14p by q. That would be the answer, right? कोई problem? Second, this is 1 by 3 raised to 15 divided by 1 by 6 raised to 15 is equal to 1 by 3 divided by 1 by 6 raised to 15, which is 1 by 3 into 6 by 1 raised to 15 is equal to 2 raised to 15. ठीक है, यही आया ना. Alternatively we can do 1 by 3 raised to 15 divided by 1 by 6 raised to 15, 1 raised to 15, 6 raised to 15, which is 1 by 3 raised to 15 into 6 raised to 15 by 1, right? इसको उल्टा कर दिया ना, मल्टीप्लिकेशन इज अपोजिट ऑफ डिवीजन. 1 by 3 raised to 15 into 6 is 2 into 3 raised to 15 by 1, which is 1 by 3 raised to 15 into 2 raised to 15 into 3 raised to 15, 3 raised to 15 कट हो जाएगा, बचेगा 2 raised to 15. Any which way you do is fine. Next, third, 1 by 4 raised to minus 5 into 2 raised to minus 3 is equal to 1 by 4 raised to minus 5. माइनस 5 दोनों जगह पे जाएगा ना. -1 raised to एनीथिंग इज 1, वो तो माइनस हो प्लस हो वो नहीं फर्क पड़ता. इंटू 1/2^3, माइनस है तो नीचे जाके प्लस हो जाएगा, विच इज, ये माइनस है तो ऊपर जाके प्लस हो जाएगा, नीचे माइनस है ना, तो इट इज 4^5 इंटू 1/2^3, विच इज 4^2 square, 2^2^5, 2, so 2^10 into 1/2^3 is equal to 2^7. हाँ, 128. यही आ रहा है, ये वाला 1 कुछ भी गंदा है बट फर्क नहीं पड़ता, एनीथिंग रेस टू 0 इज 1, ठीक है। कैलकुलेट, हाँ, सॉल्व नहीं नहीं, ये करने का ही नहीं है सॉल्व, दीज आर फ्रैक्शनल पावर्स, कौन लेगा, कैलकुलेटर है क्या तुम्हारे पास, यू डोंट हैव कैलकुलेटर, एंड एनीथिंग रेस टू 0 इज 1, दैट यू नो, वो तो पहले देखना है सबसे, नहीं वो तो दूंगा ही नहीं ना, फिर मैं क्वेश्चन कैसे दूंगा, दिए ना, फिर सॉल्व करने लायक है वो, सॉल्व करने लायक वाले दिए है, हाँ। नेक्स्ट, नेक्स्ट ये वाला, अच्छा, लेट अस सी, we'll have 1/3 raised to 4 raised to 2 divided by 9, we can write 3 square, what is this, this is 1/3 raised to 4 into 2, 8 divided by 3 square, which is 1/3 raised to 8 divided by 3 square, so this is 3 raised to -8 divided by 3 square, -8 -2, so which is 3 raised to -10, which is 1/3 raised to 10, ठीक है, कोई प्रॉब्लम, I can write 3 raised to 8 as 3 raised to -8 ना, 1/3 raised to 8 as 3 raised to -8, डिवीजन है तो सीधा सब्ट्रैक्शन वाला रूल अपना, -8 -2, -8 -2 is -10, ये 2 है ना, डिवीजन, वो ये वाला रूल अपना, a raised to m divided by a raised to n is equal to a raised to m minus n, ये वाला। देन सेकेंड लास्ट क्वेश्चन 0.5 वाला, ये 0.5 raised to 4, 0.5 I can write 1/2 raised to 4 into 2 raised to 5 equal to 1/2 raised to 4 into 2 raised to 5 is equal to 2, ठीक, कोई इशू। लास्ट, give me answer in the powers of a and b separately, what is the power of a and what is the power of b, हाँ हाँ, so you have here 1/b to the power 5p by q, 1 की पावर एनीथिंग इज 1, ये डेफिनेशन यूज करेंगे, इफ यू यूज अ डेफिनेशन a by b raised to something is a raised to something by b raised to something, a is 1, 1 raised to this 5p by q is 1, 1 raised to anything is 1, and divided by b raised to 5p by q into, now a and b, here we only have b, so we'll separate a and b, we have a raised to 9 by q divided by b raised to 9 by q, now it is multiplication of two fractions, so we have a raised to 9 by q divided by, base is same, so we add this 9 by q plus 5p by q, 9 by q plus 5p by q, which is nothing but a raised to 9 by q divided by b raised to 5p plus 9 by q, राइट. डिनोमिनेटर सेम है तो न्यूमरेटर ऐड हो जाएंगे. दिस इज योर आंसर. इफ यू वांट टू राइट बी इन द बी ऊपर लिखना है तो माइनस 5p प्लस 9 बाय q ऐसे लिख सकते हो. ठीक है, ठीक है. We'll do rest of it tomorrow and we'll start the new booklet. Hopefully we'll finish it. If you have any doubts, आज थोड़ा फास्ट हुआ ऐसा लगा towards the end, थोड़ा स्लो हो जाओ. हाँ नहीं ठीक था, समझ गए, बिकॉज सब किया हुआ था हमने, एडिशन सब्ट्रैक्शन बॉड मास सब हम कर चुके थे. डू द होमवर्क प्लीज, एडिशन के सारे प्रॉब्लम्स कल का एलसीएम एचसीएफ कर लेना. एंड अगर एक बार हम थोड़ा आगे बढ़ जाते हैं तो आई एक्सपेक्ट यू टू फॉरगेट ऑल दिस थिंग्स, सो आई विल गिव प्रॉब्लम्स बेस्ड ऑन दिस इन द नेक्स्ट मंथ सो दैट आप टच में रहो इस इन टॉपिक्स के भी. ठीक है, टेंडेंसी होता है जब उस टाइम पे जो चल रहा है वही याद रहता है, पुराना वाला भूल जाता है, तो वो नहीं होना चाहिए. ऑनलाइन स्टूडेंट्स, एवरीथिंग वाज फाइन? एनी डाउट्स? If you have any doubts, let me know. Otherwise, we'll meet tomorrow morning 8 AM.